Hi, my name is Abhinav Kumar and I'm a PhD student in CSE at Michigan State University. I'll now present our work, GrooMeD-NMS, Grouped Mathematically Differentiable NMS for Monocular 3D Object Detection. This work was carried out in the Computer Vision Lab in collaboration with Garrick, Brazil and Xiaoming. Most of the modern object detectors use a post-processing algorithm called Non-Maximal Suppression or NMS only during inference. This leads to apparent mismatch between training and inference pipelines. 3D object detection also suffers a greater mismatch between classification and 3D localization, which means the best 3D localized box might not be selected after NMS. To address the mismatch between training and inference pipelines, as well as the mismatch between classification and 3D localization, we propose including an NMS in the training pipeline, which gives a useful gradient to the network so that the network figures out which boxes are best localized in 3D and therefore should be ranked higher. NMS reduces the number of false positives and increases performance. However, inference-based classical NMS is not included in the training pipeline because it's neither parallelizable nor differentiable. Our groomed NMS is both parallelizable and differentiable. Classical NMS consists of three modules: argmax, rescore, and grouping. Groomed NMS replaces argmax by sorting in descending order. It also makes rescoring parallelizable. We first derive a recursive nonlinear closed form expression of the NMS. We then solve this approximately using matrix inversion to remove the recursion. Intuitively, if the matrix inversion is considered division and the boxes have overlaps, the rescores are scores divided by a number greater than 1 and therefore lesser than scores. If the boxes do not overlap, the rescores equal scores. We next carry out unsupervised grouping of boxes to take smaller matrix inverses. We then mask the overlap matrix to convert matrix inversion to subtraction. This expression is called groomed mathematically differentiable NMS or groomed NMS in short. We experiment with a couple of pruning functions and find out that the linear pruning works the best. We now show the final groomed NMS layer. Our loss function is the sum of losses before NMS and the losses after NMS. The loss after NMS is the image-wise AP loss, which is a ranking-based loss. Our experiments use the most widely used KITTI dataset, and we evaluate on all the three splits. We achieve SOTA results on the KITTI test with monocular images and perform competitive to monocular videos. We also achieve SOTA results on KITTI Val 1 and Val 2. We outperform baselines at all depths and at all thresholds. Our scores also correlate better with 3D IOU compared to the baselines. Groomed NMS is also a pretty good approximation of the classical NMS, and therefore we can substitute groomed NMS by classical in inference. We now show some qualitative results. We next show a short demo of our model on KITTI dataset. Our source code and models are all publicly available. Thank you for your attention.